So hi everyone, my name is Paul Koufalis. I'm here to talk to you about the poor, neglected remote client. So interestingly enough, a few years ago, I did this talk called Benchmarking Network Data Transfers, and it was really popular. I did it at a bunch of pugs around the world, and we really talked about this concept of client server and how you can optimize client server connectivity. And really, with virtualization taking over, and now you've got this hyper convergence happening, we've taken that client server level kind of to a whole other level, and application architects are requiring also now to separate the application layer from the database layer. So again, you're seeing more and more complexity, more and more issues around these network communications. So I said, you know what, it's time to do another talk, some more benchmarks about this. So who am I? I've been doing this since 1994. The fun thing is that, at Whitestar, our smallest client is like 10 users. Our largest client is 5,000 users, more now, 10,000 users. I lost track. So we kind of get to see everything. So it's a lot of fun for us. All right, so let me give you a couple of real world examples. So here's a customer we have where they have their hardware with a managed service provider. So they're paying some external third-party company to give them the hardware, give them the virtual machines, and performance was horrible. It just was horrible, right? And so we put Protop on there. The first thing we saw with Protop here is these are really slow CPUs. They had a BOGO MIPS value of 2. And to give you an idea, a modern CPU today has a value of 8, like a Xeon Gold is going to be an 8, 7 or 8, and even some of the more column value CPUs today will be in the 6 range. And so here's this customer and his managed service provider who's supposed to be giving them, latest technology so that they don't have to buy their own hardware, is giving them this crappy CPU that's giving them, throughput, a BOGO MIPS of 2, and a value of user experience shared memory of just around 100,000 or so. So we pushed the managed service provider to move them to modern CPUs, and he still put them on crappy CPUs. Here the BOGO MIPS is around 4, so it's not like he moved them to like super Xeon Gold CPUs, but right away we doubled the throughput, both on user experience LH and user experience shared memory, right? And that resolved the problem with the customer. And really, it's having this data that allowed us to go back to the MSP and say, no, like you are not fulfilling your obligations as an MSP to put this customer on modern technology, right? That's the whole point of going to an MSP. So you don't have to buy new hardware every 4 years. The MSP is supposed to do. Another classic one, if you're, there was a time when people were doing physical to virtual migrations, P2Vs, or they were just incorrectly setting up their virtual machines on VMware, and they were putting these E1000, which is kind of the default Intel NIC in these virtual machines. And it was just horrible, horrible, horrible performance across the network. And so here you can see a machine that's got actually pretty, again, 3.6 is just okay. But he can do 225,000 reads per second in shared memory, only 17,000 reads per second in client server. So really classic thing. So we just swapped out the NIC from E1000 to VMXNet 3, and then the numbers went up from there. So again, very telltale signal. And here's a bare metal server, just to show you something that's interesting about this particular customer. It's interesting that for a BOGO MIPS of 6, the user experience SHM is a little bit low, but I think it's because this is also a pretty busy machine. There's a lot of reads, like this customer does around 2 million database reads per second during a typical day. So that could be affecting it. But what's more interesting is you can see that in this bare metal server, SHM, LH, and CS, they're all around the same size. So this is possible, right? If you have your network set up properly and configured properly, and your database is configured properly, it is possible to have SHM, LH, and CS on the same order of magnitude, right? So keep that in mind. You don't have to say that the best I'll ever be able to do is, client server communications will be 25% of shared memory communication read per second. So it is possible. And the other thing to keep in mind is bare metal, I'm sorry, will always be faster than virtualization, right? Every time you virtualize or you hyperconverge or you put a SAN, anytime you do anything like that, you're adding a layer of complexity. So what are you doing? You're saving the company money by simplifying the management of the hardware, but it is costing you something. Nothing in life is free, and it's costing you performance as your data and your processing has to jump through multiple layers before it actually does the work that it's supposed to do. So bare metal will always be fastest. It'll always be faster than virtualization, all else being equal, of course. So you will make trade-offs in your company based on cost, based on performance, based on availability, right? So, VMware gives you things like vMotion that you can't do with bare metal. So you make those trade-offs as a business and decide what's the best combination of performance, availability, ease of management for your business. All right, so final thoughts to close up. Did you notice how crazy variable everything was? And that's unusual. We usually do these benchmark talks and we show you, if you do it this way, you get this result. And if you do it that way, you get that result. But that is not the case. There's too many variable factors, I guess, in these network communications. You get too much variability. And like I just said earlier, virtualization, hyperconvergence, SAN, all of these solutions are there to save your company money, to make management easier. They are not there to make performance faster, right? There is no such thing as a high performance SAN. That's Tom's favorite expression, or rather my favorite Tom expression. There ain't no such thing as a high performance SAN, right? You're making accounting decisions to save money here, all right? And the last thing, which I've repeated and repeated and repeated, test, 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 test. Before you make a change, test. Know what the values are before, know what the values are after, and especially when it's an infrastructure change, which might be 2 or 3 kind of layers removed from your OpenEdge application, having this data available to you, and then a problem occurs, you can go to the historical data and say, you know what, a week ago I was like this, and yesterday I was like this, and guess what? Today I'm like this. What did you guys do to the network? What did you do to the SAN? What did you do to the server? Oh, you vMotion me, from a super fast server to some crappy old server, and now my performance is horrible. If I have the data, the historical data, I can go to the infrastructure team and I can tell them these things. All right. So how do you do this in your office? Easy. Go download Protop from protopeurope.com. Install it on your server. The instructions are right there. There's a couple of tricky points for the client server, especially on Windows. So ping us, ping James Palmer or ping me or Tom to walk you through it. We tried to document it as well as we can, but again, you might have some questions. And then you can view the result in Protop real time. That's what Tom showed you earlier in the local character UI, or you can view it on the Protop web portal at